Welcome to our next video for Stat 212. In this video, we're going to introduce the idea of measuring risk, and just something that in the life sciences, when we're analyzing data in the life sciences, we're often going to be kind of looking at the risk of a particular kind of lifestyle choice or condition, or the benefits of different treatment, and the different ways we can kind of measure that and discuss that. So the first measurement we're going to talk about is absolute risk. And absolute risk would just be a probability difference between a certain outcome between two different kind of conditions or treatment factors or something like that. So as an example here, we have the famous Salk vaccine used to try to prevent polio. And so in this experiment, about 200,000 children were given a Salk vaccine, and about 200,000 children were given a placebo. And so what happened was the researchers waited to see how many of those children would develop polio and if there would be any difference between this Salk vaccine or the placebo group in this case. So what we can do is we can calculate the risk for polio in each of these groups, and then we can compare those probabilities to see if there might be a difference and how we can kind of quantify what that difference is. So the first tool we're going to discuss is absolute risk, or sometimes called absolute risk reduction, as we'll see down here actually. So actually I should clarify. So absolute risk would just be the probabilities themselves. Absolute risk reduction would be that difference, how much that risk changes as a result of engaging in one behavior or one treatment factor versus the other. So let's just kind of start here with what is the risk for polio in the placebo group. So it's going to be the number of children who develop polio out of the total in that group. So this is a conditional probability if you want to think of it that way. So the probability for polio given that they had the Salk vaccine, or sorry, the placebo first. So that's going to be 115 out of the 201,229 that were given the placebo. And then the risk for polio in the Salk vaccine group is going to be the 33 that developed polio out of the 200,745 who received the Salk vaccine. So if I calculate each of these probabilities out, I'm going to get 115 divided by 201,229, and I get 5.71 times 10 to the negative 4. I'm going to go ahead and write this out, though, as a decimal, just so that it's kind of a little bit more straightforward to compare these numbers. So 5.71 times 10 to the negative 4 is going to be 0.0005. So the decimal place moved 4 places over. And then the 7, 1 continuing if I want to, but I'll stop there. Whereas the risk in the Salk vaccine group is going to be 33 divided by 200,745. And that's going to be 0.000164. So we can already see that the risk for polio, kind of this absolute risk for polio in each group, is quite low, regardless of which group we're looking at. So one measure to decide how effective the polio vaccine is would just be doing an absolute risk reduction. So an absolute risk reduction would report this absolute value difference between risk for the treatment and control group. How much does that risk go down for the Salk vaccine group as compared to the placebo group? And we can do that by just taking the absolute value of the difference, or you can take the bigger one minus the smaller one, it doesn't really matter. But we're just looking for that absolute difference between these two values. So I'm going to do the absolute value of 0.000571 minus 0.000164. And if I find that absolute difference, I'm going to get, so I'm kind of doing some rounding because I'm not going to go back and use my decimals again because this is just, more for teaching more than it is like reporting these very precisely. So we just want it to be precise enough to be able to talk about it. And I'm going to get an absolute risk reduction of 0.000407. Right, and so if you think about these as percents, like if I just convert each of these over to decimal places, I'm going to get 0.0571%. This value is 0.0164%, and my risk reduction is going to be 0.0407%. So just moving that decimal place 2 places over, I can call this a percent. And I can see that my absolute risk reduction is 0.0407%. But simply noting this percent difference in risk does not really tell us the whole story, right? So, because if I'm just going by this measure alone, my thinking here is this is like nothing. Like this is a trivial difference in risk. So why would we bother with this vaccine if it's only, contributing to a 0.0407% risk reduction for polio? And so there's another way that we can kind of compare this difference from a different angle, and that would be with relative risk. Sometimes you hear it called risk ratio. However, in both cases, it's abbreviated with RR, and you commonly will see RR if you're reading a research paper that's measuring risk. And this is going to be measuring this ratio between the risks. So it tells us how many times riskier one condition is compared to the other. So in these cases where we have these kind of low incidence conditions, maybe it's a very serious thing, but maybe it's a very low incidence thing in the population. Well, an absolute risk reduction is always going to be quite small if we're already starting from a very low risk. However, when we can see that this treatment factor of interest is reducing that risk by several magnitudes, that's still notable as well, and we want to report that possibility. So we're going to simply take the risk for the placebo group. So it's going to be 0.0571, I believe. 0.000571 divided by 0.000164. And at this point, the decimal places don't really matter as much since I'm dividing. So it's really just going to be 571 divided by 164 would be the same value, but you can try it both ways and kind of verify it will do the same thing whether you keep those decimals or not. As long as I have the same number of decimals, that is, it won't really matter there. In my ratio comes out to 3.48 if I divide it this way. So now there's a couple ways that I could do this. So I did it where I did the the placebo group on top and the treatment group on bottom. However, we're typically going to do it the other way. So typically we're going to do it as the treatment group on top. So this is placebo over treatment. But we could also do it the placebo over the treatment. And so if I do that, I'm going to get 0.000164 over 0.000571. And this value is instead going to be 0.287. I think I have room there. Yeah, 0.287. So what's the difference between these two values? I guess you're not going to answer that question. But obviously, depending on which way I divide it, changes the number. And so what I could do if I'm using this number is I would say that the risk for with the placebo is 3.48 times higher than the risk for, or I should say, is 3.48 times the risk of the Salk vaccine. And if I'm looking over here, the way I could interpret this is saying the risk for polio with the Salk vaccine is 0.287 times the risk with the placebo. So it's just all a matter of which way you're kind of making that interpretational statement. Like they're both meaningful values. You just have to make sure that you're interpreting it the right direction. So it's the risk of this top group as compared to the risk of the bottom group. So in this case, we're just going to typically stick with this ordering. So we're typically going to put, oh my goodness, I can't write anything correctly here. Sorry. This is supposed to be treatment over control or placebo. So we're typically going to go with this route over here, where we do the treatment group, this kind of factor of interest, divided by this comparison group, this standard treatment group, this placebo, whatever it is that we're kind of using as a benchmark. But again, it's subjective. I can interpret it either way, but we'll just kind of stick with this default pathway in this class. So if I go this route, then my interpretational statement will be that the estimated risk of contracting polio after taking the Salk vaccine is 0.287 times the risk for polio after taking the placebo. So one thing that we can notice here is that if our relative risk is below 1, that means that the risk is going to be reduced if we're talking about people in this top group, whoever we're talking about up here. If the relative risk is above 1, it means that the group that we're listing on top has the higher risk, right? So I don't think that's pretty hard to figure out mathematically, right? So 1 is kind of our standard though, right? So a relative risk of 1 means that we have equal risk in both groups. So below 1 or above 1 is just telling us which group has the higher risk. All right, so we could also use absolute risk reduction and relative risk in the case of kind of comparing side effects of a particular drug. So over here, what we're doing is comparing the risk of something bad happening, and the agent is something that is supposed to prevent it. So basically, we're deciding, is this agent actually preventing this bad thing from happening? Now we're going to use these same measures, and now our context is going to be, is this bad thing increased? Is it more likely to happen as a result of this agent? So here we're going to look at it in the context of the side effect of a particular drug. So here we're going to look at the side effects of Viagra in terms of producing headaches. So here we have some data. We have 734 folks who took Viagra, 725 who took a placebo, and we can see how many of them had a headache or didn't have a headache. How different is this? How can we measure this? So first, let's start with absolute risk for headache while taking Viagra and absolute risk for headache while taking the placebo. So maybe you can try this on your own, but it's going to be 117 divided by 734 for Viagra. So this is the risk with Viagra. And then the risk with the placebo is going to be this 29 over 725. So 117 divided by 734, and I get 0.4466. Over here, I got 29 divided by 725, and I'm going to get 0.04. So those are pretty big differences already. And that's because I did my math incorrectly on my calculator. I was like, man, that's a really big difference. It's 117 divided by 734, and that is 0.159. Okay, so what is this absolute risk reduction of headaches for taking the placebo rather than taking Viagra? So notice how we're going to kind of alter this phrasing to match what we're measuring here. So if we're talking about absolute risk reduction, we're talking about the risk being reduced. So in this case, the risk is being reduced by avoiding Viagra. So we could also say that, like, what is the absolute risk reduction for headaches for those who avoid Viagra in favor of a placebo? And that, again, is going to be this absolute difference, or absolute value difference. And that's going to come out to 0.119 if we calculate that out. So the risk for a headache is reduced by 11.9% for taking the placebo and avoiding Viagra in this case. But again, this is kind of a misleading measure. In this case, it's, the risk is apparently high enough and normal enough in the population that we can see a notable difference, 11.9%. But relative risk is a direct comparison of the likelihood. It can tell us how many times greater the risk is for one agent as compared to the other. So let's do the relative risk for headaches when taking Viagra as compared to the placebo. So we're going to do risk for with Viagra divided by risk with placebo, and that's going to come out to 0.159 divided by 0.04, and this is going to be about 4 times that of the other. Let's see, so 0.59 divided by 0.04, and I'm going to get about 3.985 here. So that means that the risk for headaches with Viagra is 3.985 times the risk for headaches with the placebo. One little thing that I'm going to point out here is it's really tempting, and I even tried to say it earlier, really tempting to say 3.985 times higher than the other risk, but it's actually 3.985 times the risk. And that little nuance just has to do with the fact that, like if I say that there is an increase by 100%, what I'm really saying is it's twice as big. Whereas if I were to say that that this is 100% of that, I'm actually saying that they're equal. So if I go back down to like a relative ratio of 1, and I were to say that something is 1 times larger, that would be kind of a confusing statement because it might make you think that I'm trying to say that it's double. If I say that it is 1 times larger, so instead I'm going to say that it is 1 times that of, or is 100% of this. So we just kind of want to watch our language. So instead of saying it 3.985 times higher, we're just going to say it's 3.985 times the risk of the other agent.